For decades, Boeing stood as an undisputed titan of aerospace, synonymous with engineering excellence and safety. But that reputation was shattered by an unprecedented crisis. In late 2018 and early 2019, two brand-new 737 MAX aircraft, fresh off the production line, plunged to Earth, killing all 346 people on board. These weren't isolated incidents, they exposed a systemic failure that reached deep into the company's design process, regulatory oversight, and corporate culture. We delve into the true causes behind these catastrophes, uncovering the intertwined factors that created a deadly scenario for Boeing's next-generation workhorse. The first disaster struck on October 29, 2018. Lion Air Flight 610, carrying 189 passengers and crew, crashed into the Java Sea shortly after takeoff from Jakarta. Just 5 months later, on March 10, 2019, Ethiopian Airlines Flight 302, with 157 people aboard, met a similar fate, crashing 6 minutes after departing Addis Ababa. The similarities were chilling. Both were brand new 737 MAX 8 aircraft, both experienced erratic flight paths, and both pilots struggled valiantly to regain control against an unseen force. The world demanded answers, and investigators quickly homed in on a common culprit, a specific flight control system unique to the 737 MAX. The heart of the problem lay within a system called MCAS, or Maneuvering Characteristics Augmentation System. Introduced on the 737 MAX, MCAS was designed to automatically push the aircraft's nose down under certain flight conditions, preventing a stall. This was necessary because larger, more fuel-efficient engines on the MAX altered the aircraft's aerodynamics, giving it a tendency to pitch up. Boeing's solution was a software patch rather than a costly redesign. But MCAS had a critical flaw: it relied on a single angle of attack (AOA) sensor, making it vulnerable to a catastrophic failure if that sensor provided erroneous data. And that's exactly what happened in both crashes. MCAS, as designed, could repeatedly push the aircraft's nose down, overriding pilot inputs, based on faulty data from just one sensor. If that single angle of attack sensor malfunctioned, sending incorrect information indicating a stall when none was occurring, MCAS would activate. The system would then command the horizontal stabilizer to repeatedly push the nose down, believing it was preventing an imminent stall. Pilots, unaware of MCAS or its aggressive nature, were left fighting an automated system that was actively working against them. The fatal consequence was an unrecoverable dive, forcing the planes into uncontrolled descents that ultimately ended in tragedy. Forensic analysis of the flight data recorders from both Lion Air 610 and Ethiopian Airlines 302 revealed a chilling pattern: wildly divergent readings from the two angle of attack sensors on each aircraft. In the case of Lion Air, one AOA sensor immediately provided faulty data, indicating an excessive angle. This triggered MCAS to continuously command nose-down inputs for the duration of the flight. The pilots attempted to counteract this over 20 times. Ethiopian Airlines pilots faced a near-identical scenario. The repeated erroneous activations, stemming from a single, unreliable sensor, were the direct mechanical cause that baffled and overwhelmed the crews. Beyond the technical fault, deeper questions emerged about Boeing's corporate shift. Historically, Boeing prided itself on an engineering-first culture, where safety and robust design were paramount. The 737 MAX, however, emerged from an era increasingly dominated by shareholder value and aggressive cost-cutting. The decision to implement MCAS as a software fix rather than a more substantial airframe redesign was emblematic of this change. It allowed Boeing to market the MAX as a common type with the previous 737 generation, minimizing pilot retraining costs, a key selling point for airlines. This trade-off between engineering integrity and commercial expediency proved catastrophic. The pressure on Boeing wasn't internal alone, it was fiercely competitive. Airbus had launched its A320neo, a fuel-efficient version of its popular single-aisle jet, which was quickly racking up orders. Boeing needed a swift response. Developing an entirely new aircraft would have taken years and billions. Instead, they opted to heavily modify the existing 737 airframe, creating the 737 MAX. This urgency to compete, coupled with the desire to avoid extensive retraining requirements for pilots transitioning from older 737s, heavily influenced the design decisions, including the controversial implementation of MCAS. The market dictated the engineering compromises. The development timeline for the 737 MAX was aggressive. From concept to first flight, the process was compressed, driven by the imperative to deliver the plane to market quickly and retain Boeing's dominance in the single-aisle segment. This rapid development schedule contributed to critical oversight. Teams were under pressure, and the intricacies of new systems like MCAS might not have received the thorough, multi-layered scrutiny that a more deliberate development cycle would have afforded. The focus was on speed and meeting airline demands, potentially at the expense of comprehensive safety validations, especially for a system with such significant implications. Another critical layer of failure involved the Federal Aviation Administration, the FAA. For decades, the FAA had delegated significant portions of aircraft certification to the manufacturers themselves, including Boeing. This Organization Designation Authorization (ODA) program meant that Boeing employees, acting on behalf of the FAA, performed inspections and approved certain aspects of the MAX design. This system, intended to streamline certification, created a clear conflict of interest. The very entity motivated by commercial success was also responsible for ensuring its own safety compliance. Critics argue this blurred line severely compromised the independence and rigor of the certification process for MCAS. Investigations revealed alarming deficiencies in the 737 MAX certification. Crucially, the FAA was not fully aware of the extent and power of the MCAS system. Boeing had provided incomplete documentation, downplaying its impact. The original MCAS design allowed only one activation per flight, but a last-minute change allowed it to reset and activate repeatedly, making it far more dangerous. This critical change was not thoroughly re-evaluated by regulators. Furthermore, the single sensor input for MCAS was deemed a catastrophic flaw that should have been identified. The process failed to catch these fundamental design vulnerabilities, directly contributing to the crashes. Compounding the technical and regulatory failures was a severe deficiency in pilot awareness and training. Boeing deliberately omitted MCAS from the 737 MAX flight manual and pilot training materials. The rationale was to minimize training requirements, allowing pilots qualified on older 737s to fly the MAX with minimal additional instruction, often just an iPad course. This decision saved airlines money but left pilots dangerously unprepared to recognize, understand, or counter the aggressive, uncommanded nose-down inputs from a runaway MCAS. In a crisis, their training did not equip them with the knowledge to identify the problem or the procedure to disable it effectively. Disturbingly, the cracks in the system were visible internally. Reports and whistleblower accounts later surfaced, revealing that some Boeing employees had raised serious concerns about the safety and certification process of the 737 MAX. Messages between employees, including test pilots, showed an awareness of MCAS issues and pressure to cut corners. One particularly damning quote from a Boeing employee stated, "I basically lied to the regulators regarding the aircraft's safety systems." These internal communications painted a picture of a company where commercial pressures sometimes outweighed safety imperatives, and where critical warnings were either downplayed or outright ignored, to tragic consequences. In the wake of the second crash, the global aviation community reacted decisively. Country after country, starting with China and eventually including the United States, grounded the entire 737 MAX fleet. This was an unprecedented move for a new commercial aircraft, signifying a monumental loss of confidence in Boeing and the regulatory bodies. Over 400 aircraft were immediately taken out of service. The grounding, which lasted for 20 months in the US and even longer in other regions, sent shockwaves through the airline industry, causing widespread flight cancellations, massive financial losses for airlines, and deeply damaging Boeing's reputation and financial standing. The financial fallout for Boeing was staggering. Analysts estimated the total cost of the 737 MAX crisis to be well over $20 billion, including compensation to airlines, production cuts, legal fees, and fines. Orders for the MAX plummeted, and numerous airlines canceled their commitments. Boeing's stock price, once a consistent performer, endured significant volatility and decline. The crisis forced the company to halt production of the MAX for months, furloughing thousands of workers and severely impacting its supply chain. The reputational damage was immeasurable, taking years to even begin to repair. It was a stark lesson in the true cost of compromising safety. To get the 737 MAX back in the air, Boeing embarked on a monumental effort to redesign and recertify the MCOS software. The updated system now takes input from both angle of attack sensors and will only activate once. Furthermore, it cannot repeatedly push the nose down, and pilots have clearer, more explicit controls to override it. Comprehensive pilot training programs were developed, emphasizing MCOS and runaway stabilizer procedures, including mandatory simulator time. After rigorous testing and review by multiple international aviation authorities, the FAA finally ungrounded the 737 MAX in November 2020, followed by other global regulators in the months that followed. The crashes of the 737 MAX were a tragic and costly lesson for the entire aviation industry. They exposed a dangerous confluence of flawed design, insufficient regulation, and corporate pressure. Boeing has since committed to a renewed focus on safety and transparency, overhauling its engineering practices and relationship with regulators. However, rebuilding public trust, both from passengers and airlines, remains a formidable challenge. The legacy of the MAX crashes will forever serve as a cautionary tale that in aviation, there is no shortcut to safety, and the true cost of compromise is measured not in dollars, but in human lives. The skies are safer now, but vigilance is constant.